Thanks, Pete.
Thanks, Michael. Very much appreciated. Um, yeah, thanks everyone. Well, the title for today's sort of CPD session is about the practical approaches to water safety. And I thought I got a little bit excited about this, thinking I'll just get my crayons out and start drawing and painting a picture of all of the experiences that we've come across, or some of them, I should say. And it's quite revealing. Some of the things that people do, the aspects that you come across on a day-to-day basis. And the majority of these, we deal with various sectors within different markets. So we look at education, we look at property, we look at healthcare, we're looking at local government, universities, housing associations, etc., etc. So a whole myriad industrial settings, with a whole myriad of different sort of remits and issues that we come across. But unfortunately, most of the photographs that we're going to come across today are predominantly from the sort of healthcare. But that doesn't mean that these healthcare situations they're exactly what they are for everybody else. They are learning experiences. Okay, so without further ado, I'm going to take a little look about practical approaches to water safety. Now, can I ask if we've all seen these crazy photographs regarding health and safety? I'm sure we have. We've come across them lots and lots of times. There's going to be more generated like this, I think, with AI and all that sort of stuff. But this is an old one. It's a goodie, but it's an old one. And the practical approaches to water safety presentations are along similar lines as to these photos. So it'll be demonstrating some of the things that we found with water systems and how not to do it. Okay, so there's another one, another good quality one where a forklift is lifting another forklift up for a heavy piece of kit to get to a next platform. And we can see a whole myriad of things that are not quite right there. Okay, so what do we mean from a water perspective? Well, the practicalities of these various components of a design, structure, implementation, design and build, and ongoing contamination and ongoing control measures. We seem to be getting a lot of people coming through here, Rosemary, late on. 111 people, that's not a bad start. Okay, so the practicalities we're looking at. The practicalities are design and install. We're looking at components, we're looking at safety, we're looking at contamination, temperature monitoring, sampling, and record keeping. And at the very beginning, we really want to get involved in that design and install aspect, which is where we've got project water safety engineers, we've got project water safety groups, and the designers, the architects, and all of these people, the M&Es, all of those people that get involved. And what they tend to do at the minute is they tend to design a system that is risk averse, but that risk aversion can often lend itself to issues further downstream, which mean that when we actually practically run these properties have got failings in regards to water safety management, specifically Legionella or Pseudomonas aeruginosa potential. So we're going to go over a few of those in a bit of detail. Okay, so design and install. Yeah, let's start at the very beginning. So let's get it right at the design stage. And I'll be saying that phrase quite a lot today. So how many organizations have got a water safety group or a water hygiene team? How many of those groups or how many of those water safety groups have got a project team or a project team representation? And a water safety group that actually review the intended plan and sign off. So does the water hygiene team and all of those people involved in it, if there are any, more than one or more than two, do they get a look at how a new build or a refurbishment is going to go ahead? How is it going to be designed? How is it going to be installed? And therefore, what's the impact on the ongoing maintenance and management aspects of it? So, experience with a project where a specialist water system was installed in the middle of the building on boosted water supply, which served all the cold water outlets. And this area not having a dedicated water supply meant that future maintenance, i.e. disinfection of the boosted water, would be detrimental to the specialist water system. So including the installation of alternative water treatment strategies such as chlorine dioxide, copper silver ionization. HSG 274 Part 2, paragraph 2.48 details the stagnation of the water system during construction time as being a potential issue for biofilm formation, and as such, bi-weekly or twice a week flushing alone will not suffice. And the contractors do not appreciate that water sat around only being flushed twice a week presents a risk, especially when they've left site. So we need to make sure we've got daily flushing with additional of chlorine dioxide, for example, 1 to 3 ppm is suggested as a means to reduce the risk of biofilm formation. And the issue with chlorine dioxide being used as a control measure is often a last-minute thought, which has not been budgeted for and the lead time not considered. And there is also the suitability of the chlorine dioxide or the product, the supplementary control measure, being dosed. And manufacturers have actually detailed that dosing 3 parts per million would invalidate warranties on their products. Albeit the guidance details a range of between 1 to 3 and not 3 ppm. So it's not as clear as it would be and should be, and it should also be reviewed by the Water Safety Group and signed off. So at the outset, we've got particular problems with things like stagnation, water being involved and introduced and therefore having stagnant. The contractors have got to take ownership and responsibility. They should be looking at supplementary controls if they can't flush the system. How is that therefore managed? And then does that get removed before it gets handed over to the end user? There's lots and lots of things to take into consideration, and that's why that design and install and the project water safety group team members have got to be involved in liaising with the estates departments and whoever is going to be handed this refurb building or new property over to be able to manage. Okay, so let's get to the actual bits and bats. So we've got fixtures and fittings, we've got pipework, we've got valves, taps, thermostatic mixing valves. These should all be kept free from debris and possible contamination through the delivery to site, while stored on site and during the installation. So as we can see on the right hand side, there are 3 sets of taps, or 3 taps, and the left hand side one and the far right hand side one has got a bag, it's covered, it's as kept clean as it possibly can, whereas the middle section there, the middle one, has actually got no control measures in order to stop any debris or detritus or contamination. And we've also got a little view here of some pipework that's been capped off. There's no potential for contamination on this particular one, but here, here, and here, they also need to be capped off and remained free. So open ends on pipework and components that are not kept sealed will invariably suffer from ingress of debris and contamination. So this is just a bog standard site that we've come across and partway through an installation process. But whose job is it to make sure that these things are actually done? Well, we used to have a person who was, well, I wish they were back introduced into the businesses, but clerk of works. So these clerk of works used to go around and check things were happening or was happening or wasn't happening and make sure things were done in the correct way. Now, we don't often have many clerks of works now going to view these things. So whose responsibility is it to make sure that these things are done? Unfortunately, it's the contractors and also the site's responsibility who's going to get it done in the future. We're going to get that building handed over to them in the future, especially the project water safety group team or the projects team or the capital teams or whatever we want to call them. Okay, so here we've got balancing valves. Yeah, those have got to be set correctly. So 75% of returns are not balanced or circulating. Therefore, we've got areas for Pseudomonas aeruginosa and Legionella positives potential due to that stagnation. And the contractor had come back to put these right 2 years after the work was completed, and the ward was closed for 2 months. Okay, what was the issue? It was poor configuration, the position of the returns, balancing of the system, strainers and filters. Yeah, who was the culprit? Well, the design and the build contractor. And like I said before, if we can get this right at the design stage, we've got to make sure we've got to have competency of contractors, evidence of performance at handover, making sure that these systems have been flushed regularly, we've had supplementary measures if needed, or temperature control has been adequate, or commission cleaning, disinfection processes, and subsequent sampling at the end of it to make sure you've been handed over a clean system. We've also come across things like this, which is labelling up a pipework. And as we can see, we've got a hot water supply flow coming there all the way through to here. And then all of a sudden it changes into a heating return. Yeah, so correct labelling of parts of the system. Yeah, it goes from hot water to heating return system. These are often done right at the end of the projects where people have made a rush in, maybe don't pay as much attention to detail, and they've got a bit of time pressures. But again, it's something that we need to look at and make sure that these things are performed correctly and handed over adequately. We've also come across things like this. Now, On the right hand side there, we have got a shower head and hose, and it's now unfortunately touching the sink basin. So whatever's in the sink basin is now potentially on that shower head, and obviously there's a bit of cross-contamination occurring. And on this one, we've actually got a radiator-like type design. So somebody had asked for this to be installed due to the fact that they wanted to dry their towels on this concoction of metallurgy and pipework. And when you're asking a contractor to do that, they should be competent enough to say, well, actually, that's not quite right. We shouldn't be doing it. We shouldn't be elongating pipework. We shouldn't giving it areas where it could potentially stagnate, etc., etc., etc. So there's lots of things that could have been and should have been said before this was even installed. So we've got to make sure that the competency of the individuals who's asked for this extra, and who's the person who's installing it, are they fully aware of the implications of actually trying to do it or wanting to do it. Okay, so are we aware that these flexible hoses cause us a bit of a problem? So rubber is an organic material, and rubber is a fantastic food source for a location where biofilms can form. If biofilms can form, Pseudomonas aeruginosa can form, Legionella proliferation can also form. And these biofilms, or these flexible hoses, are internally made of rubber. And rubber is like I say, great. It's porous. It's got lots of holes, nooks, crannies, crevices, etc. And it's got a perfect location for bacterial growth. Now these was particularly fitted in an augmented care. Yeah. So the contractors, specification of work, projects, the capital team, evidence of handover, risk assessment at handover has identified that these should have been hard plumbed in. So there should have been copper pipework and tails fitted to the taps. The reason why these were installed, because it's easy. Yeah, it's quick. It's unfortunately not the right thing to do in augmented care facilities, but also not the right thing to do in general because of the potential for that rubber internal to be contaminated. Even if they are RAS approved, the recommendation should be that they are hard plumbed in as best possible. And also on the right hand side here, we have got a thermostatic mixing tap, and that thermostatic mixing tap is being supplied by a thermostatic mixing valve. So when this new tap was installed, the person who was doing the installation should have actually identified that that was no longer needed, therefore should have been removed. And what we are doing now is we're giving it a location for bacteria to form in here, which then is going to be supplying 38 to 42, 43 degrees centigrade. And if anybody knows what temperature Legionella proliferates the quickest at, well, it's 37, it's closest to body temperature. And 37 degrees is not too far away from this temperature within this system here, feeding that hot tap. So that really is a location where things could occur that we really don't want them to. So again, we need to be looking at the competency of the people who've asked for it and competency of the people who are installing it. We've also got something else here that really concerns me a little bit. We've got a Belfast sink and an ordinary basin. So my question would be is, do both of these facilities get used on a regular basis? So is this one used on a regular basis, and is therefore this one used? Or as humans, we're creature of habits, do we go to the same location and we start to think that this may well be an infrequently used outlet? If it's an infrequently used outlet, do we actually need it? Yeah, why install it if it's leave it in the staff room? Okay, now then, these are historically, these expansion vessels could be found in any plant room at all. And the expansion vessels are fitted with a flexible hose with varying length. And as we can see here, we've got a large length of pipework, a flexible hose there, which again is rubber. But internal of these expansion vessels is also a rubber diaphragm, rubber lining. And if there's any splits in this rubber lining, water can get to the back of it and can start to form a bit of a growth or a bit of a biofilm, which is apparent here. So that is what can be found inside an expansion vessel. And the new expansion vessels have changed design from these type, where there's a way in but no way out. We can put a what's called a flushing valve in there, which makes sure we've got flow going in and flow coming out. but also the new design of flow through. So we have water going in and we have water coming out and reconfigured into the system, so it's not wasting water. Those are the better methodologies, or the better type systems. The ones with water in and no escape have got a real opportunity for proliferation and damage to the rubber bladder or diaphragm. They should also be flushed and have the ability to be flushed. Yeah, and as we can see there, if there's no flushing valve, we've got a potential for stagnation, dead end, and obviously some the risks associated with that. And now we're looking at internals of taps. So these are the internals of taps. So we've got filters, we've got strainers, etc., etc. And if I was to say to you, this is many moons ago, when there was a bit of work going on outside from the United Utilities, for example, or any utilities, let's say Yorkshire Utilities, we used to get an ingress of dirt, debris, sediment coming through our taps. It's not quite as common as it used to be, but when I was a kid, I'm pretty sure that we had it on a regular basis, that we had to flush our outlets and make sure that the tank is clean, etc., and make sure we post through some of the sediment and gunge that was coming through from the previous, or the works further down the road. Well, that sediment can start to form and start to sit in filters, valves, strainers, wherever it can fit, it will go. And that is, again, a fantastic food source. It needs to be regularly cleaned, disinfected, and reinstated and commissioned and signed off again. Yeah, but that again goes down to any adequacy of any maintenance programs. And again, who's responsible? Well, the competent person's responsible for stripping down, cleaning things, disinfecting things, and making sure that they're done on a regular basis or as per the manufacturer's guidelines. And as I mentioned before, I'm going to mention again, if we can get it right at the design stage, right first time, it's a lot easier said than done. If it's installed correctly, it reduces the risk and reduces the impact on the maintenance aspects moving forward. So it's a bit of a win-win. The system's designed to be as least potential for proliferation, but with the least potential for proliferation often becomes a saving in maintenance requirements further down the line. So installation or mechanical and electrical engineers, design houses, they like to be averse to risk, and they like to install thermostatic mixing valves to avoid scalding. Now, obviously, we'll do a scald risk assessment to make sure we're not putting the people at risk. And if there is a requirement for a thermostatic mixing valve, then we install one. But if there isn't, could we remove a suggestion that a thermostatic mixing valve was needed? Because if we do, we reduce the impact, we reduce the risk, but we also reduce the ongoing costs further downstream. So remove the design risk. Yeah, do not buy a car that needs 3 litres of oil every day. Competency of those designing it. Probability not enough deaths from Legionnaires' disease each year to warrant domestic hot water. So that, what we mean by that is we did a presentation once to a group of designers, and one of the designing bodies there wasn't particularly interested. And we asked them why not? Any particular reason why you're not as interested as some other people within the group? And they said, well, Legionnaires' disease has not killed enough people. And we were taken a little bit aback by that. And our suggestion was that is one person's death one too many, if we're looking about how we design and have a system there to reduce the risk. Yeah, does that make sense? And we want to design a system that is a minimal risk whilst also conforming to the other safety aspects of a design, install, and components aspect of a new build or a refurbishment. So also the water safety group involvement. We need to get these people involved, and what I mean by that is any water hygiene team. So who's the responsible person, who's the appointed person, who are the competent people, and can we make sure that they understand the risks associated with the new design? Again, are thermostatic valves needed? Designers are risk averse and put them everywhere in our findings. And from this review, we can look at various things such as best practice, good practice, conventional practice, or outdated practice. And ALARP as low as reasonably practicable, which is highlighted in British Standard 8580 for Legionella risk assessments. There's a British standard guidance on contractors, and it's not necessarily, contractors are not necessarily always up to date. The approved code of practice and British standard 8558 2015 is obviously often quoted as standard for cyst disinfections. Well, that 2015 revision of 8558 saw its own British standard disinfection, published document 855486, and some people don't refer to that aspect, and that's what I mean by outdated practice. Some things have been superseded, and again, I appreciate that architects, contractors, etc., they can't always be up to date with the most current guidelines, but it is helpful if you have an organisation that you know, whether it be the Water Hygiene Centre or somebody internal, that can actually assist with these project designs, design reviews, and making sure that they are conforming to best practice or good practice, if not best practice. And a project plan's obviously needed. Project plan, when is the actual building going to be handed over? And we need to work back to include commissioning, evidence that it's safe, sampling, and time. And obviously we need that time to fix any issues, etc., that may have arisen prior to handover. And we've got some photographs of cold water storage tanks. And these cold water storage tanks were this one's sited outside. And from a risk perspective, what is the risk associated with this? There's an accessible ladder, top of a cold water storage tank. It's a reasonable size cold water storage tank. It's a Braithwaite tank. It's what, 2.25 meters by 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12 meters. So it's quite a chunky amount of water. So it's probably going to be at a large facility. But what's to stop somebody climbing up that ladder and throwing something into that cold water storage tank? So again, we've got to look at the risk associated to these things. It was accessible from the road. There was no access gates, etc. And these things are issues that we come across on a regular basis. And obviously, we've got certain things here with ladders. We've got cable trays. We've got lots of things that are not quite right. Yeah, it's actually so safe access, not a ladder. Actually, it's a cable tray in the tank room. What about these things? Point of use filters. Did we come across point of use filters? And if so, what's the quality of those point of use filters? Now that one has been cracked, and what's the efficacy of those filters that have now been cracked or functioning incorrectly? What's the efficacy of this filter that's been removed? Was it removed because it was a lack of pressure? Was it removed because it's out of date? If it was out of date, where's the new one that's gone onto it? Why do we need them? What for? Yeah, so if the protection's obviously failed here, and that's not suggesting that the pallet got a faulty piece of kit, but that's had something hit it, looks like. And also this one here has been removed, but for what reason? And has it been reported? Was it removed by a patient, customer, client, etc.? And has it had has that failure or fault been raised with the powers that be? And we see this on a more often than not basis. So these are mops. So these are mops that have been obviously mopping floors, etc. And these mops are now sited or situated within a basin. And that sink has got an outlet, and that whatever was on the floor from the mop head is now touching the tap outlet. So it's transferable cross-contamination again. That can cause us problems, but also the fact that we have locations here which are infrequently used. So what's the likelihood of this shower being used on a frequent basis? Probably slim and none. We've seen many pictures and photographs of infrequently used outlets, which are in rooms. We've come across them. We do risk assessments to say, does anybody use water in this room? No. Okay, so why is there a live sink, or why is there a sink supplied with water there? It's got a point of use heater. The heater's not working, etc. Okay. Also, the contaminate this length of hose. So it looks as though we've got a bit of a section there that's keeping that hose up from touching the floor. Yeah, ideally we would like a hose that couldn't touch the floor, even if that was broken. Yeah, to avoid that cross-contamination. Okay, so we've got picture one, inappropriate installation, backflow issue, contravention of water safety regs. We've seen similar already with the shower head and hoses reaching wash hand basins. It's exactly the same situation. And picture 2 is a little used outlet. Again, a little used outlet, inappropriate use. It's a storage facility. And again, competent persons, healthcare workers, HTML 401 details the training of those that can impact on water systems. Okay, so picture 1, we've got a point of use filter installed on this outlet. Not the wrong thing to do. However, it's below the spillover of the wash hand basin, so therefore backflow issues. So ideally, we should have installed a point of use that is above, or the outlet is above the spillover. Picture 2 is inappropriate use of the wash hand basin, little used outlet or frequently used outlet. Medical devices stored. Again, competent person, healthcare workers should be trained, should be aware that that is not the right thing to do. From a personal perspective, yeah, we're looking at personal hygiene, personal health issues, and screening. The requirement of HTML4 to complete a health screening is part of training. Yeah, who is doing this? Anybody? My suggestion would be not many. Cleanliness of tools. So when, as a plumber, a plumber who's working on your system, as they attend site, do we know what the cleanliness of their equipment is? Do we know whether they've been disinfected prior to use? Or have they just gone from another facility with a risk issue over to your facility, where there's again potential for contamination? Cleanliness of tools, clean set, dirty set, pseudomonas aeruginosa investigation, single bed ward wet rooms, for example, or water all over floor and tools, footwear, floor, doesn't help with the PSA investigation. And again, the competent people should know how to make sure we've got things in our ducks in a row. From a temperature monitoring perspective, we all know that we should be temperature monitoring, and we've got some various pieces of kit in front of us there. We've got an infrared, we've got a probe, and we've got a bog standard thermometer. Okay, so does your water safety plan define your method for taking a temperature and the calibration of such thermometers or equipment? And those who take temperatures, have they been trained in the defined method? And the reason being is because we can have various tools. We can have a contact probe, we can have, as I said, immersion probes, we can have temperature gauges, we can also have temperature gauges in our clarifiers, cylinders, hot water cylinders. And that contact probe that's just there's a need for a heat sink grease, a lubricant, and it can give us a difference between 3 to 6 degrees. And that difference has a big impact if you're achieving 44, 45, 46 centigrade. If you don't have that heat sink, you may be giving yourself incorrect information. And then what action to take if the parameters are not achieved? So temperature monitoring is not just a case of we'll take a temperature and we'll write it down. It's actually understanding what do we do if the temperatures are out of specification or not being achieved. Okay, we may well have seen drawings like this in our Legionella risk assessment documents. And we're looking at a cold water storage tank, we're looking at a hot water cylinder, it's got a shunt pump on, etc., etc. And where are our nearest and farthest outlets? Where's our recirculating system? Where's our primary loops, tertiary loops, secondary loops? How often do we take temperatures within our cold water storage tank? How often do we take temperatures of our cylinders? What methodology do we use? Is it recirculating system? And the return loops are the hidden elements of the system which traditionally have not been measured, checked. Although the revision in 2014 of HSG 274 Part 2 and the 2016 revision of HTML4 Part B, there is a need to identify these loops and then identify how to best take the temperatures, whether it be manually, whether it be monitoring connections or BMS or other remonitoring systems. One of the things that we consider on this aspect of to which piece of kit we decide to use would be accessibility, cost, time, and effectiveness. We've also got these types of kit. This is an infrared probe, and unfortunately, they've got their drawbacks. Yeah, and we need to have a tape with a specific emissivity value in order for the reflection of the laser to be removed from the result. And position of the laser sight isn't where the temperature is taken. What do we mean by that? Well, as we can see, if we take a snapshot of a wall and the wall temperature was 27.1, we also take a snapshot of the infrared light or beam looking as though it's on a person's body. Now, if that person was actually 28.6 degrees, I would assume that that person wouldn't be alive for much longer. And unfortunately, this is looking like it's more realistic. That's about, what, a good centimetre, 2 centimetres above the finger, but that's actually reading 35.4, which is more realistically biased towards a human temperature. And also, it's not a good idea to have one of these in your hand baggage when you go through an airport. Yeah, I know somebody who's had one of these in a hand baggage or hand luggage, and security were alerted as it looked like a gun, and issues with a laser pointer and where it is aimed. Okay, what about the gauges and the BMS? So the gauges, when was the last time we had our temperature gauges and our cylinders calibrated? Yeah, they're often not calibrated, but they can be, they often relied upon. They shouldn't be. Yeah, they're an indicator only. Yeah, BMS systems, calibration requirements. How is data stored? How is it retrieved? Client BMSs, once gone off the screen, no record saved. Yeah, for example. Is the knowledge of the BMS capability truly known? Who reads the instruction manual for these things? Can we keep records? Can we retrospectively go back 3 months, 4 months? We've also got an opportunity to learn how to take some samples. So the water safety plan is there to obviously define sampling methodologies as well as part of it. And the guidance on how to take samples exists. The blue book on the left-hand side is from the Environmental Agency. It's free, and also we've got the British Standard 7592, which is a bit of a cost. The water safety plan needs to detail sampling strategies and the need to use accredited laboratories. We need to make sure we take them correctly, we make sure they're stored correctly, they're at the right temperature, they're delivered to the site correctly or the lab correctly, and the UCAS accreditation methodology is adhered to and is being performed and being obviously witnessed and checked and assessed to make sure it's conforming. We've also got in the water safety plan, we need to detail actions to take with Legionella positives or any positives. And HSG 274 offers a small table for actions to take with positive samples. Okay, so not detected or up to 100 colony-forming units per litre. Primary concern is protection of susceptible patients. 100 to 1,000. If the minority of the samples are positive, the system should be resampled. If similar results are found again, review the control measure and risk assessment to identify any remedial actions. But if the majority of samples are positive, the system may be colonised or at a low level. An immediate review of control measures and a risk assessment should be carried out to identify any of the remedial actions required. Disinfection of the system should be considered. And obviously greater than 1,000, the system should be resampled, immediate review of control measures, and risk assessment carried out to identify any remedial actions, possible disinfection of the system, retesting should take place a few days after disinfection, and at frequent intervals thereafter until a satisfactory result is obtained, or control is obtained. We've also got a health technical memorandum, part B, details pre and post samples. So we've got, not only do we have to take the sample correctly, but we have to have the right methodology. Do we take it pre or post? How do we take that sample? And there's lots of things to figure out. We've got some information here as to whether it's pre-flush samples, post-flush samples, and the plan of action to go along with it. If it's a local or systemic issue, then we may well need to go back to the design and installer. How many samples were budgeted into the entire project through construction to handover? Yeah, so at the design and installation phase, have we actually managed this process? Have we thought about it? Because we have to make sure that we sample periodically through the construction, and then obviously we need to make sure we sample at the end of the installation to make sure that the handover can go ahead and everything is tickety-boo. And you need to be assured of the quality of the water. So a few samples post-disinfection won't cut it. Yeah, weekly samples through a defined plan to bring assurance of the water quality is needed. Now, weekly samples at the end is probably going to be more beneficial. And obviously then you need to take a view on that as to how much has been budgeted for, etc., etc. But that needs to be raised as within the process as possible. Okay, sampling. How do we sample? Yeah, we should not use untrained individuals. We should not flame the outlet. We should not take Legionella and Pseudomonas aeruginosa samples at the same time from the same outlet. We should not deliver samples beyond the agreed times, 24 to 48 hours. We should not use volumetric multiplication for sample, and we should not use a non-UCAS accredited laboratory. We've also got a bit of a video on the Water Hygiene Centre website, and that's called Legionella sampling, and it just tells us how to or how sampling can be undertaken. From a documentation perspective, record keeping. Yeah, we've got to make sure that these records are quite robust, yeah, or very robust. They are performed by competent personnel, trained personnel. Do we know the difference between training records and competency records? So the training records are things that we've attended. Yeah, we've been on a training course, etc., etc. Okay, brilliant. Will we assess for suitability at the end of the training course? If so, brilliant. Did we pass? Okay, great. But also, have we then been assessed performing the job? Have we been assessed and appraised by line management, by our organisations, who then witness us taking these samples and actually performing the standard operating procedures or risk assessment method statements correctly and accurately? So that the key aspect of competency is, have we been assessed for suitability to carry out certain tasks? And with this goes record keeping. Yeah. So has it been done? Has it been accurately? What was the methodology of taking it, etc., etc.? And we've got two different sheets or two different bits of information on here. Yeah, and as we can see, the building says Matt, location, boiler room, the date, 7th of 7th, what year? Not sure. Thermometer read number, not sure. Okay, if it's not sure what thermometer it is, how can we keep a record as to whether it's been calibrated? When was the calibration last? Don't know. Okay, and here we've got system reference 1, 2, and 3. Okay, so gauge broke. Okay, flows 50, returns 48, cold 21. Secondary domestic hot water pump working, no. D-strap pump working, no. All acceptable, yes. So how can that be? Okay, compare that to this side. Okay, 702, yeah, 58 degrees. The gauge reading was 61. Perfect. So, okay, so yes, yes, no. Why not? 702 checked for lunch. So that was slightly low, 58 degrees percent, slightly low. So we checked after lunch at 1:30, or that person checked it after 1:30, and it was 61 degrees C, therefore it's all unsatisfactory. 703, gauge faulty reported, ticket item number 1123 to be replaced. Okay, this one, the middle one, is a lot more detailed than this one. Which one would you like to hang your hat on? I know I'll go for this one. Okay, so we've got to make sure that the documentation that we are reading or somebody is performing or producing on our behalf is accurate, detailed enough, and would withstand intense scrutiny. Should be the opposite way around. A little joke by RMD, he does like this one, it's wrong on all levels. Okay, so we're going to look at lessons to be learned. So this prosecution was because of an outbreak of Legionnaires' disease in Hereford in 2003. 26 cases of Legionnaires' disease and 2 deaths. This was caused by a cooling tower at a site called Bulmer's plant, which were being looked after by Nalco on Bulmer's behalf. Yeah, but both the client and the contractor were held responsible because Bulmer's wasn't checking what Nalco was doing, and Nalco didn't do a particularly good job, and evidence that Nalco staff hadn't signed out the key to access the cooling tower. The HSE warned the organisations that they cannot absolve themselves of responsibility simply because they have an appointed contractor to carry out the work for them. And Bulmer's and Nalco were actually fined £300,000 each, plus costs of £50,000 each. So a significant fine due to the fact that they'd not taken ownership and responsibility of each party's contractual obligations or responsibilities from the Health and Safety Work Act. So, who is actively checking work completed by contractors? Next one is, in 2011, there was one death at the Brighton and Sussex Hospitals NHS Foundation Trust. And an investigation found that between October the 10th and November the 11th, there was 114 positive Legionella samples taken, and 651 records of non-compliant temps. Chlorine dioxide at 5 sites failed to dose correctly, and there was no adequate action recorded for any of these findings. So who is actively checking work completed by competent persons and resolving? Okay, we're going to look at this one, which is one death in 2012, down to poor maintenance, poor training. And this was, the failings were systemic, across the Reading Borough Council and continued over a period of time. There was a history of Legionella problems at the home, which was formerly known as Tanfield Care Home, and the monitoring, checking and flushing tasks were given to the home's handyman, who was inadequately trained and supervised, and there was no system in place to cover for him when he was away, so that the requisite checks were not done. The Legionella training of the key personnel at the Willows was significantly below the standard required, and there were inadequate temperature checks. Some of those done with respect to thermostatic mixing valves were done incorrectly. Showers were not descaled and disinfected quarterly as required. Flushing of little used outlets was reliant on one member of staff, and there was no procedure for this to be done in the absence of that member of staff. So what we're talking about there is a deputy. So have we got a person who's taking responsibility of the task? But what happens if that person gets hit by a bus or is ill or on long-term sick? Do we have a deputy that can step in and continue doing the monitoring and the management of those particular areas? And can that be as smooth as it possibly could be? So who has the training needs matrix that is reviewed by the Water Safety Group and training delivered? And again, to the deputies, the deputy needs to know as much as the person responsible for doing the job, because as I say, what they need to be able to smoothly step into doing that job on an ongoing basis if needs be. And we've also had an issue at the Royal United Hospitals Bath, NHS, one death, 2015, no monitoring in place, strain of Legionella not the same, prosecution for exposing patients to risk, and the site was fined £300,000 and £37,451 in costs. Okay, so who has a risk assessment review matrix to capture change to systems? So this particular situation was due to, in fact, a building that had been installed or refurbished, or built, sorry, I should say, not refurbished, built, nobody knew about it, and nobody knew that it needed to be onto this list, or the people that needed to know didn't know, let's say. So people knew about the building, but they didn't know that they needed to tell the specific people. And the people who were looking after the water hygiene management aspects and making sure that they had risk assessments in place, they didn't know that this building had been installed, so therefore there was no, or this annex, I should say, they didn't have a risk assessment to it. So unfortunately, somebody did contaminated Legionella. It wasn't the same one that was found within this building, William Budd, up next door to the William Budd, and it caused a bit of an issue. So people have got to know what buildings have been installed, what buildings are going through a refurb, and what is part of their remit. That's one of the hardest jobs to do, is to make sure you understand your portfolio of properties. As I say, who has a risk assessment review matrix to capture any changes to systems? So historically, we used to have a time frame where risk assessments needed to be completed every 2 years. That was in the book, that was in the documentation. Every 2 years, without fail, we did a risk assessment review. That's been changed slightly now to things like, has the system changed? Has the building changed? Are people within the building, have they changed to a dramatic impact? So was it once a school and now is it a COVID centre, for example? Has there been any changes to documentation, legislation? Have we been involved in a Legionella outbreak, or has there been serious major changes to personnel involved? And if that is the case, they therefore then need to have a risk assessment review process. So instead of the 2 years, it may be before 2 years, or it may be after 2 years. But instead of taking that time frame out, it's now become a risk assessment-led approach to a risk assessment review. What are the changes to it? Okay, so we've not mentioned one particular outbreak, and that was Barrow. And Barrow occurred back in 2001, 2002, and this lady, unfortunately, Gillian Beckingham, was unfortunately the person who was took the brunt of the issue. 6 major failings or major findings were associated with this Legionella outbreak in Barrow in the town centre, and that was poor lines of communication and unclear lines of responsibility. There was a failure to act on concerns raised and advice given. There was failure to complete risk assessments. There was a poor management of contractors and documentation. There was inadequate training and resources, and there was individual failings. So unfortunately, as I said, this lady took the brunt of it because she was found under individual failings. They were deemed as being incompetent. She was an architect, was Gillian by trade, and unfortunately took a £15,000 personal fine, and it didn't do much for her architectural career. So she was fined. She was between 2002 and 2006. She was initially charged with manslaughter, and she was initially charged with manslaughter but found guilty of health and safety breaches. So between 2002 and 2006, her life must have been hellish. And yeah, as I say, she was a person that was deemed as responsible for making those failings and mistakes. Okay, so finally, we're looking at a 3-year mean, 2017 to 2019. Now, you may well ask, where's the data for recently, between 2020, 2021, 2022, 2023? But there was something else that was about at that particular moment in time. And 2020, in March 2020, we know that COVID occurred, and unfortunately, the powers that be, the Public Health England, had a different fish to fry, and there was no records kept from 2020 to 2023 in regards to Legionella month by month and confirmed cases. The cases are now being reported again, but this is now via another organisation within the Public Health England called NOIDS. And those numbers aren't quite exactly what they once were before COVID. They're a lot less. So there's a suggestion that we're underrepresenting or underreporting. But as you can see, these were the figures between 2017 and 2019, and the red columns are 2020. Okay, so as we can see there, it's a summer sort of disease. It's more prevalent. Why? Because the temperature ranges between 20 and 45 degrees C. It's warmer. We've potentially got more stagnation in domestic properties because of holidays, etc., etc., etc. So there's lots of things that we can talk about there. But temperature range is predominantly the reason and the rationale behind why we get increased in the summer months. Okay, so people have got to be confident that the organisations that they use are adequate. So water safety groups and water hygiene companies and water hygiene groups need to be satisfied of the competency of the risk assessor, evidence of experience in interview. Yeah, how do we go about gaining that information? Well, the LCA, the Legionella Control Association, has got 300+ members registered to deliver risk assessments. Which one do you pick? And how to filter further, and this is where I'll do a little bit of selling for the Water Hygiene Centre. The Water Hygiene Centre are a UCAS accredited laboratory, UCAS accredited risk assessment organisation. There are only currently 15 companies registered to deliver UCAS accredited risk assessments, and the Water Hygiene Centre is one of them. We're totally independent, so we don't do any of the water hygiene monitoring, sampling, cleans, disinfections, shower disinfections, valves. We don't sell anything other than consultancy. And for your information, we've got a website there which is heavily weighted towards these things, which is subscriptions. We do blogs on a regular basis, and there's also an academy videos there to tell you how to do things, or to be explained how to do things. We're on LinkedIn, Facebook, and Twitter, mostly on LinkedIn. And yeah, we send these weekly blogs out. You can subscribe to these blogs. And it's about experiences of the senior consultants and also their clients. And we often get information from clients and ask the clients, what do you want to hear a blog about? What do you want to know about? What do you want to learn about? And we'll write a blog and we get them published in various articles and various publications. They used to actually ask us to pay for these publications, but now they're coming to us and asking us, can we publish these on behalf of you? Which is great because it's free, but it also a bit of advertising, and also gets a bit of credibility to the senior consultants who've had 10 years plus experience in water hygiene. And I've gone through a lot of documentation there and information, so this is a bit of a flashcard. The approved code of practice, HSG 274, part 1, 2, and 3. We talked about the health technical memorandum. We've got the Scottish health technical memorandum, British standards, published documents for flushing disinfections. We're looking at BSE NA06, specifications for installations inside buildings, water quality risk assessments. We're looking at water quality risk assessments for Pseudomonas aeruginosa as well, and other waterborne pathogens. So there's lots and lots of information that we obviously we glean and we get our knowledge from, and it's something that we expect not everybody's going to want to read. So it's therefore, that's why you rely upon organisations like ours to make sure that you're following the information, the guidelines, and the legislation accurately and correctly. So, without further ado, I would like to say thank you very much for your time. A bit longer than I anticipated, but has anybody got any questions that they would like to ask? How's the chat gone, Sarah? Oh, I can see it's already okay.
There are a couple in there, Pete. I'm not sure if Sarah's. So I've got one is, what is the water hygiene centre view of WRAS approved flexible braided rubber hoses?
Oh, say that one again, Rosemary.
What is the water hygiene centre's view of WRAS approved flexible braided rubber hoses?
Well, okay. Even though they are RAS approved, they've still got rubber internals. In a perfect world, could we potentially hard plumb in and not use the flexible hoses to reduce the risk? I appreciate that that's not always the case. The risk associated to them is relatively low. However, they do need to be changed on a frequent basis if you are going to go down and continue using the RAS approved braided hoses.
Thank you. And then we had one that was, I can see how this relates to hospitals and care homes, but is there a specific risk assessment for GP practices? Gardner says it is the responsibility of the landlord. It's difficult to get confirmation of compliance from them. What would a practice manager, who's usually the water responsible person with no water safety experience, be expected to do?
Okay, great question. Okay, so if you are a tenanted property and you've got a landlord, what is your contractual obligation with that landlord from a regional perspective? If they say that is your responsibility, then a risk assessment would need to be produced. We do lots and lots of GP practices. They invariably are located, depending on the size, number of partners, etc., number of GPs. They vary in price. They can be, rather in depth if it's a large sort of primary care facility with GPs in there and operations may be occurring, or it may well be a small practice with just a couple of combi boilers, etc., etc. Do you want to give us a buzz, Hilary, and we can chat that through a little bit with a bit more detail?
Okay. And then the last one is dosing with chemicals effective and recommended to prevent Legionella in H and W water systems.
Okay. Now then, where was that? Just say that one again, Rosemary, for me, please.
Is dosing with chemicals effective and recommended to prevent Legionella in H and W water systems?
Okay, personally, the best way to manage your Legionella proliferation is through temperature. So temperature is well known for being the best methodology of controlling waterborne pathogens. It's relatively straight. If you don't take anything away from this today, take this away. If you keep the hot, the cold, keep it all moving, keep it clean, and keep it well managed. That is 5 points that we can hopefully be of interest. But the hot above 50 or 55 degrees C, depending on what scenario you're in, environment you're in. Keep the cold at less than 20, as cold as possibly can be, because at that stage the Legionella proliferation is dormant. Not a lot of things grow at low temperatures, and we don't do an awful lot of moving, so that bacteria is not proliferating very quick. Its growth range is between 20 and 45 degrees C. So either side of that is good. The hotter it can be, the better. The quicker it's killed. Stagnant water, keep it all moving, keep it clean, and keep it well managed. Well managed is the key, making sure you've got your outlets and everything that's being stored correctly, distributed correctly, return valves and return processes with accurate disinfection of shower heads, scale on your taps and your outlets, etc. From a dosing of chemicals, that's normally done due to the fact it's a supplementary measure. So if you can't control it through temperature, is there an option to dose with supplementary measures, and that involves either chemicals or ultraviolet disinfection processes. Various products work on various other types of systems. There's not one that fits on. That's a one-stop shop. Not one product that will do everything for everybody. And again, you've got to look at the options available to you, the ongoing maintenance, whether you want chemicals on site or what it is, and how you dose, how you manage. So firstly, can we engineer out the risk by having a good temperature control? Does that make sense to whoever asked that question?
Hopefully. And the one from Paul is, can you have a thermostatic mixer valve and a standard mixer tap?
And you have a thermostatic mixer valve and a standard mixer tap?
Yeah.
Great question. Let me come back to you on Paul. Is that Paul, right, asset manager? Yes.
Yeah.
Let me come back to you on that, Paul. Let me get a proper answer on that.
Okay. And then another one here from Chi is, if staff capacity is an issue for flushing, would it be ideal to use auto flushing systems to mitigate risks to little used outlets? Yes.
Okay, so these auto flushing valves have been around for a while. They are improving. They are not the silver bullet just yet, but they are much more improved. So they are well worth a look at if you've got locations that are difficult to access, or you know that there's for whatever reason, staff shortages, etc. And if you know that these are little used outlets, can you get them onto an auto flushing regime, and with a good quality piece of kit that is proven efficacy and is fit for purpose? Yes. Well worth investigating.
Oh, another message down here. I think it's just thanks coming in now. I don't think there's anything else. Sam Allen is just asking if you offer a CPD on the WRAS approved products, etc., like selection of materials for potable water systems.
Oh no, we don't. But we did. That's a great point, actually, because that's a bit of a moot point, actually, because we were going to develop a water regulations presentation. So let me raise that internally.
I think that is it. I think I'm going to double check the chat. We've got both of them going now. So no, I think that's everything. I think we've answered everybody's questions. I think Michael sadly had to leave. He had to leave about 1:30, I think, for another meeting. So just for me to say thank you very much indeed for that. There's a lot of great thank you messages coming in and saying what a great session it was. So thanks very much. I said all who really attended today, I will get the CPD certificate sorted and get those sent out to you sometime this week. And the recording link will be sent out to you once I've done a little bit of editing. But thank you very much.
Perfect. Thanks, Rosemary. Thanks, everybody, for your time. Much appreciated.
Lovely. Thanks very much, Pete.
Cheers. Thank you. Bye-bye.
Thanks.